Kumar, sir,
Yes, ma'am. I'm here. I think my voice is clear, no? Hello.
sir, good
Yeah, my
afternoon, sir.
voice is
Welcome,
clear,
sir.
right?
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
Sir, shall we wait for few more minutes or shall we start, sir?
It's okay. 2 minutes, no problem.
Thank you, sir. Thank you.
But I have a hard deadline at 3:30 because I have meeting with director.
Yes, sir. Yes, sir. Actually, we are waiting for more number of participants. They are joining now.
Yeah, no problem.
So, shall we start now, sir?
Yes, ma'am. Please.
Yes. Thank you, sir.
Ma'am, shall I start or what is the
Sir,
procedure?
1 second, sir. 1 second.
Yeah, sure.
Kartika, Kartika,
Yes, ma'am.
please
Good
start.
afternoon, everyone. Good afternoon, everyone. A very warm welcome to the chief guest, Shantakumar Mohanar, and welcome every voice matters and every journey adds to the richness of a shared experience. So, on this occasion, I would like to, excuse me, sorry for the interruption. Welcome to one and all gathered here for the 5-day FDP on empowering educators, AI in robotics, and automation for innovative initiatives in the digital era, organized by Department of Mechatronics Engineering by Sri Krishna College of Engineering and Technology. I'm pleased to invite Professor Shantakumar Mohan as our esteemed chief guest, bringing expertise and inspiration to elevate our event today. Currently, he is serving as technical editor of IEEE and ASME Transactions on Mechatronics Associated, editor of IEEE Robotics and Automation Letters, and ASME Letters in Dynamic Systems and Control and Robotica. He is also an adjunct professor at the Department of Engineering Design at IIT Madras and faculty fellow at the IIT Palakkad Technology iHub Foundation. Have done multiple projects in the field of mechanism design and analysis and service and field robots under water vehicles and manipulator system. Thank you, sir. And over to the presentation.
Yeah, thank you. So I'll start sharing the screen so that it will be clear. I hope you are able to see my screen, right?
Yes, sir.
Okay. So I'll just brief. So this talk may not be that longer. I am trying to give a glimpse of what is mobile manipulator and specifically how it is going to change the industry or what are the challenges in mobile manipulators. That is the whole idea here. So before that, as similar sense which I used to do it, you see, I am coming from IIT Palakkad, which is one of the IITs in out of 23. So this is located in Palakkad. Most of you may be knowing where Palakkad located, and but not many of you may be knowing IIT Palakkad. So IIT Palakkad come in the third generation of IIT. The student strength is around 1,300, and the faculty strength is around 120. This is the sanction strength. So we may actually get it 2,500 in another 5 years. So that is the ministry target. So apart from that, we have all, you can say, infrastructure which is required to execute all kind of research that you can actually like have a chance to visit our open day where you can see all our research facility. Apart from that, if any of you are willing to use our, you can say, high-end research equipments and also you can actually like contact through our central instrumentation facility or iSTEM portal through that. So you can have a chance to, you can say, use our facility for your research or your basic, you can say, regular experiments. In addition to that, recent days we are allowing even institutions to visit with their students also as a small visit. So the prior permission is there, then you can also visit. So this is what all about IIT Palakkad. So we have two campus, which is actually like across this road. So this is the road which is actually separating our two campus. One is Nila campus, which we call transit campus, because this is the one which we started even before building the main campus. So the main campus we call the Sagyatri, which is the mountain around the, you can say, Nila river called the Sagyatri. So the river which is passed start from actually like Palakkad and pass through which we call Nila river. So this campus called Nila. So this is the background. Let me come back, although like she mentioned something. I just give a small introduction about me in you can say line with this particular talk. Okay, so I started working on robotics probably in 2002 when I was 2000 itself. So when I was second year in BTech, so there only I started working on robotics. But my you call enhancement all happened in IIT Madras when I started working on field robots specifically. So that too like underwater robot, which is much more different than the other field robots. And I was working on, you can say, practical system. So I was working with one of the, you can say, naval research laboratory, so which is actually like NSTL we call Naval Science and Technological Laboratory Vizag. So this particular lab and IIT Madras had one project where jointly working on in developing underwater vehicle for naval purpose. So this is the project which I was working as the project student. Then
Salsa. Gerald, please wait for a while. Some network issues here.
I'm really sorry. When the connection is broke, I didn't know. So anyone can say.
Yes, sir. Yes, sir. No issues,
Yes, sir,
sir.
yes, sir.
Just a
No
few
issues.
minutes before, sir.
Yeah, okay. So I'll just start sharing the screen again. Yeah. So I think I'll just come back where exactly like I want to discuss. So I don't want to actually like keep pushing you. So you can see, right? So this particular talk, as I already told, it is mainly focusing on one particular topic. So that particular topic I want to give in a perspective why this is important for the robotic engineer. That is the whole idea. So in that direction, so I'm just focusing that particular part. So we all actually like bother about industries, right? Specifically, like if you look at it, most of the institutions, Industry 4.0 as a mandate course. I hope in Sri Krishna also like Industry 4.0 is one of the important element. But you just imagine why this industry evolutions or revolutions happen. So that, if you look at it, then the topic which I am focusing also may be easy to understand. For example, when the people, or you can say when the humans start growing their, you can say, territory, so then they need actually like some kind of uh, you call something like they need, or you can say they have to fulfill their demands. That is more easier way to put it. So in order to fulfill their demand, they need to see how to fulfill that with the help of their own resources. In that sense, the resources are very much limited, because before the industry evolved, so mostly like it is with the basic science. So basic science in the sense of small liver wheels, that kind of thing. Apart from that, what helps actually like all the effort come from the man or human. So the human manpower, or you can say the human power or the animal power, may not be sufficient to fulfill the demand which was rising that point of time. Then people thought, okay, why can't we think about some kind of mechanization, use of some external power? Fortunate that we had a steam engine, then we start getting it. So because of that only, we all got the industry evolution. So then this is not the point which I'm actually like focusing, right? So then you can see even further demand keep increasing. The mass production is supposed to be the fulfill point. Then the electricity bond, the mass production has come. So even that is not sufficient for the demanding and the expectations, because once the demand is fulfilled, the expectations keep increasing, right? So then the expectations keep increasing. The perfection is important for making the demand fulfilled with the perfection. So you need automation. For making automation, actually, like semiconductor industry start booming, and then we got something like Industry 3.0. Even now, we are actually like at the stage of Industry 3.0, because 4.0 is not much change. But now, if you look at it here, so what happened in Industry 2.0 to 3.0? There is a different entity called automation, along with one another guy called robot or robotic system. This is where actually like we are actually like focusing. Now, Industry 4.0, what happened? This is physically connected the human and the robot within certain cell, right? But if it is cyber connected, then that is what we call Industry 4.0. So in the sense, this is actually like a kind of network connected and need not to be present next to that. So that is what we call Industry 4.0. I'm not focusing on Industry 4.0, but the thing which I'm actually like trying to focus, you see the pictures which I have shown, you would have noticed. So here there is a manipulator which is fixed base, but you can see Industry 4.0 is giving one additional thing. So the base is not fixed. In the sense, something evolving where the manipulator on top of the vehicle base is actually like by default has come in the Industry 4.0. In that sense, you can see like the vehicle manipulators or mobile manipulators are actually like upcoming area in terms of Industry 4.0 or in the modern world. That is what the whole idea. In order to understand this, I tried to give kind of definition of the robot and as well as classification of robots. So the definition of the robot and classification, I'm going to do it in a physics sense. So that means, so I'm going to call robot or robotic device as a effector. So what that means? So this has an effect on the environment. So any robot or robotic device that has an effect on the environment called effector. Okay. So now this effect on the environment causes motion of the effector itself called locomotion, but the effect on the environment causes motion of the objects around called manipulation. So now the manipulating device called manipulators. So for specific definition, so robotic manipulator we are going to focus, because mechanical manipulator, even you can say bio manipulators are there. So we want to classify robots. So robotic manipulator is one idea. So the other one is the locomotive devices in terms of robot, which we call mobile robot. This is what the classification which we are going to do, and this is the way I'm going to define the robot also. Okay. So now you got idea. So one is actually like one end is fixed, the other one is actually like it is actually like mobilized, right? So in order to get understand, you can see the ball and human in between the ground. If you look at it, if the ball is actually like in between ground and the human, when the human is start moving his leg and he is able to stabilize, he will move along with the ball, right? So now the human being is actually like lying on the ground and he is moving his leg on top of, you can say, his leg, there is a ball. This ball is actually getting manipulated. That is what the basic definitions and the classification which I am interested to inform. So now, if you look at that way, so one is actually like very, very simple because it is constrained workspace and it has actually like absolute measurements, and sometimes it may not be required the world around that. But when you go to the other side where the mobile robot, the environment is unconstrained, and in order to understand the, you can say, functional thing, it's supposed to know where it is and what are the things around, right? So in order to give more clarity, you can see this is the so this is the manipulator and this is the mobile robot. You can see like, so now the effect is actually like hitting on the ground, the wheel is hitting on the ground, the effect on the environment causes motion of this mobile base. But here you can see that effect on the environment causes the motion of the objects, which is here the, you can say, small cylindrical objects. These are the things. Now everyone can immediately ask the question. You take any animal, even from small amoeba to even human mankind. So everybody is having a both capability. So they can actually like mobilize and as well as it can manipulate. For example, even you take an ant can actually like manipulate object even larger than its height, weight. Even you take a dog, you throw a ball or bone, it can manipulate and it has a mobility, right? In the sense, when you talk about this manipulator and mobile base, it is not touching our reality, right? So then you can actually like ask, sir, why can't we take this and put it on top so it can create a mobile manipulator? Yes, that can actually like provide some kind of advantages like what disadvantage has in mobile base or manipulator that can change and provide advantages, but this is going to be a complex system. So in order to understand this complexity, I'm just giving a very simple example. For example, so the small kid is actually like standing on the floor with a barefoot and it is holding a toy. The toy dropped unknowingly and the baby is actually like bending and lifting it. The baby will not fall. But now imagine that the same baby is actually like on a skate wheel, or you can say it is on a roller. Okay, so now similar way the baby actually like dropped the toy and it is trying to bend. Do you think that this similar situation can happen? No. Why? Because because of the body motion, the body I am talking about, the multiple body which is associated with the baby. So when this is actually like bending, this motion actually like causing the, you can say, effort on his foot. Earlier, fortunately, the friction had a three-dimensional vector and it is sufficiently strong enough to avoid the, you can say, fall. But the second case, the roller, which is actually like making only vertical reaction, which is pointing upward all the time, and which is actually like not able to overcome the effort. This you would have noticed when you are looking at the vehicle manipulator, which is a broader one or bigger one. You have seen day-to-day life when you are seeing in a construction site the backhoe, right? The backhoe is actually like, or we call JCB clean and all, right? So that has a long arm that has a bucket or you can say some kind of digging tool, right? So that when it is actually like digging with a wheeled base, you would have noticed that the driver always elevate with the two arm with the front and he put the bulldozing tool also in the back. So in the sense he tried to make it at least three or more point contact so that it can actually like avoid the, you can say, the dynamic coupling between the manipulating body to the wheels. That is what happened. Now you can see like one bigger issue, the dynamic coupling. Apart from that, like for example, you want to keep one object in three-dimensional space. So how many degrees of freedom we require? So three translation and three orientation, which you can simply say 6 degree of freedom, right? But now imagine still we are operating in three-dimensional space. And if you look at this manipulator has a six joints and this mobile base having magnum wheel base, imagine. So it can actually like move in longitudinal lateral and it can rotate about its Z axis, right? In the sense it can go in a plane three motion and it can actually like have six motions. So now you are combining this, what happened, the degree of, you can say, mobility or mobile manipulabilities increase. So now kinematically it is actually like more degrees than the required degree of freedom. The degree of freedom is still 6, but you have degree of, you can say, freedom to mobilize this object is more than 6, which means so it is actually like the kinematic redundancy is providing more challenge. So what challenge? For example, you have 6 equation and 6 unknown. You can straightforward solve as long the equation is actually like linearly or it is simply independent equations, like whether it's a linear or non-linear. If it is a independent equations, you can solve it 6 by 6 will get right. But imagine you have actually like 9 unknowns and you have 6 equations. So what happened? So you can have multiple solution, right? So if you have multiple solution, it is very difficult to get it which is better, right? And how to calibrate. For example, I want to keep my pen in one pose, but my leg can actually like mobilize. Even I can actually like hold my arm permanently. I can mobilize myself and I can hold my wrist and then I can actually like rotate my shoulders. So many things happen, right? Because I have free motion which is possible. So these are the few challenges which is encounter in the mobile manipulation. Although mobile manipulation is by default as a entity which is everybody is looking for, but the challenges are like this. Okay. So this is what I want to say. For example, any you can say man is actually like doing a small mobile manipulation every time, right? For picturizing, I'm saying that the stone is actually pushed by the human. He is actually like getting mobility and as well as manipulating this rock, right? And this is another way you can see olden days. So they want to mobilize and manipulate this object. So this is mobilizing and this is for manipulating, right? If you release this, you call catapult. So it will actually like throw. This is manipulating. But the stone and along with this is mobilizing, right? So, and this is what I said. You can see there is a two support, and this bulldozing tool would be actually like rested so that this can actually like do it, right? So this is what the simple mobile manipulators which we are focusing. Now you can ask how this is actually like in an upcoming area, or why you are saying in an upcoming area. So for that also I have some answers. So just to give that idea, even so the robotic word, although coined later part of you can say 70s, 80s, but the robot or robotic research started in 60s, 70s all start getting a prototype, and 80s the prototype start getting matured and manipulators start coming in 85 and 90 beginning, right? So the theme of the robotics is not changed since then. There are two broader theme people work in robotic researchers. So there are two themes I said, right? The theme also like easily classified. One is actually like you can say money minded. The other one is actually like human minded. So one is actually like humanity side. So the other one is actually like kind of efficiency or profit oriented. So both are important in the modern days, and even 60s onwards, people are working it. So very simple example I'm just trying to say, you would have noticed in the news and all, or probably some kind of even article you would have seen, people developed a winking robot, a smiling robot, laughing robot, dog, a pet bot, like that. So many articles you have seen, or so many actually like news also you would have seen. So then if you are digging at, so winking robot, they spend 10 lakhs and making a winking or smiling or emotional robot. Why they are spending that much money? And is it really usefulness? If you look at that way, then you will feel like something strange. But you have to see the other side. So what is the other side? So the other side is actually like the human should have the welfare, or you can say comfortness. The comfortness will be provided by something. Very simple example. So you all proudly saying that India is having a largest youth population whenever you go abroad. But imagine 10 years or 20 years down the line, you would be having large middle or probably elderly age people, right? So then how will you make them happy? So now itself actually like our community has changed. Wherever you go, residential complexes, so the pets are not allowed. At least earlier, single child or single grandparent are there, they used to grow some pet animal to give a or you can say company, right? Which we call peer group attraction. But now that is also not allowed. Most of the residential complexes or you call apartments, right? So then how will we do that? So you need some companion robot, right? That companion robot should have the mobility and as well as manipulability, right? That is one thing. And second thing is the industry oriented, which we call profit oriented or money minded. There also you would have seen that the layout, when I was a student, the layout is very much fixed for the industry layout. From the raw material to the finished product, the layout is fixed like a conveyor base or some kind of, you can say, mechanized manner. You send the raw material, at the end you will say the finished good. But now that kind of, you can say, layouts are not so popular. Why? Because the variability and customizations are actually like too key in the modern industry. So in that sense, you have to actually like see flexible layout. If it is a flexible layout, then you should have mobile manipulation is one of the inherent part, because you have to handle the material from one station to another station. If it is a variable, you have to adjust that and adapt that. So you need to have a flexible layout. So in that direction, so I'm just putting it this two broader theme. One is actually like a human oriented companion robot. The other one is actually like kind of smart intelligent robot, okay, which is usually like this. So you can see that the dog robot is replacing the dog. It is not really replacing because there is no affordability, so they are able to afford the dog robot. The dog robot should do how the dog has done. So in the sense, it should have a mobile manipulation. So now imagine here I am putting it, you can say power plant inspection. So you know power plant condition monitoring is not that easy. So many valves, so many meters, so many actual like you can say control unit, everything you have to do. For example, I ask you to go to engine lab. So how many you can say meters are there? How many valves are there? You note down the position every half an hour or every 2 hours once. It is a fatigue job. But imagine power plant is so many things, and you have to actually like monitor that, and you have to control based on the action. So in that sense, if it is actually like robotic system, that to have a robotic system with mobile manipulation as the entire entity, that may be actually like much more. Now you can see that it is actually like taking a Photoshop photo or image of these all the unit, and immediately it is processing, and it is actually like indicating the you can say condition based on the pattern which is already we have fed it. So now based on that, it can give the command to the other, you can say, mobile manipulator, which are actually like responsible for closing or opening the valve or controlling the system. And now you can see based on the command, it is actually like closing the valve or opening the valve. Okay. So this is what we are trying to say, in the sense the mobile manipulator is actually like indispensable in terms of in the modern world. So one is actually like human friendly companion robot, so which we are actually like envision like this. The other one is smart industrial autonomous robot, which is what we are envisioning for the flexible layout. So these are the two broader things. You can see that mobile manipulator is by default everywhere it is going to come. Okay. So in the sense, if you talk about mobile manipulation, what are the ability you have to see? So the abilities are actually like, so obviously it's supposed to actually like manipulate, it's supposed to actually like mobilize, right? So ability to move, ability to interact, which we call manipulation. So these two are actually like by default the name itself. So apart from that, what are the key ability you need? So it's supposed to actually like ability to sense, right? And ability to think and ability to communicate. So these are the process, and specifically like these two are actually like very important, because you can provide sensor, but the perception is actually like much more enriched by the capability, and sometimes these sensors are actually like which we are actually like bothering. So now, in that sense, we are actually like moving one step further. So the control aspect, as I already mentioned, it can be teleapp, so which means remotely operated. So in that sense, the human control is actually like very important. Is actually like going to control. But what we are always anticipating that the fully autonomous, but fully autonomous is very expensive and required lots of sensing and processing. So people usually compromise between these two. So the some of the, you can say, very routine things which require less intervention, that would be given to, you call, you can say, robot itself, and some of them would be taken by the human, which is we call shared autonomy. But in between there is a supervised autonomy or shared autonomy, you can take it. Supervised autonomy is in the sense you allow the robot to do autonomous operation, but under the human supervision. Whenever there is something, you can take over, the human will be take over the robot. That is the call to supervised autonomy. So now you might be getting a small glimpse of mobile manipulation, how it is actually like evolving. So let us actually like go little further thing. I already actually like justified in one sense, but further sense I am actually going to justify. For example, when the robots start coming, so people assume that it's a wild animal. Why it is so? Because robot can harm or the humans can harm the robot. It is like bringing a tiger into a village without any, you can say, prevention. In the sense safety is almost zero point 0.0. Okay. So that way only it was there. So then people actually like tried to bring that into industry with the, you can say, human robot collaboration by a fixed fence. So what that means? So we are bringing the safety 1.0. So we bring the wild animal with a cage, like for example, to bring it to the zoo, or you go to zoo, you can see the lion, tiger would be in the cage, and you can look at them in the sense both. For example, Chennai, you can say the Vandalu Zoo is located in Chennai, and human also living in there, but it is in a cage, right? That is what the first safety 1.0. But this is actually like restricting lots of things. Why? Because the human, whenever he wants to cross, he has to stop. He has to actually like remove the cage. In the sense, he has to open the door and go and correct it. So, which was actually like not attract for the industry people. Then they brought some kind of virtual fencing. Okay, so uses laser, or you can say some kind of IR light kind of thing. So whenever something is crossing, it will actually like give a termination signal. It is almost still as a fence, but only thing the fence is actually like virtual fence. This is also not attracted by the, you can say, industry people. Okay, so then what they made it actually like they put it a virtual guard, but what happened? So here the sharing is not possible, right? So here actually like they put it a sharing. Okay, so one robot to another robot, even human, can go whenever they intervene in within that operating entity, it stop. Otherwise, it is actually like still workable. In the sense, you can see the sharing workspace has happened, but still the human robot collaboration did not happen. So then people start working on this. So which is what we are actually like looking at even in the modern world. This is what happening. So there is no laser or virtual barrier. So it is actually like the workspace is shared between one to another. So now you can see the one engine part is actually like assembled one part by the robot, the other part by the, you can say, humankind. Now we are actually like still moving further. So for example, the robot and, you can say, human is actually like sequentially doing, right. So now that sequential can be a responsive one. So in the sense they can together can work any joint venture. This is what we are looking at. So in the sense you can see like this. See, even if robot is not responding or human not responding, we can correct it. This stage. But these all actually, like you would have noticed, the industry was looking at a fixed base. But what we are looking, we are actually like moving on a flexible layout. So then, so we are actually like coming to the current stage, which is the sixth stage, where the robot is actually like not only fixed, it is autonomous collaborative robot, which is combining all the, you can see, positiveness, and you have seen that still this is exist. But what happened? There is a mobile base with manipulator is coming. That is actually like controlling. This is what nowadays we are envisioning, and some of the industry also you would have noticed. Even the Ola scooter industry, you would have seen that they have several mobile manipulator and mobile robots, which is making the layout. Because the manipulator you would have seen many places, but now modern world is coming with this way. So in that sense, you can see mobile manipulator is, even in industry perspective also, it is keep booming, right? So that is what I just want to convey. So in that sense, modern autonomous mobile manipulator is actually like multiple fold. It is not only, you can say, industry, it can actually like work for even a domestic, or it can actually like go for medical. Everywhere it can actually like go. For example, medical. So during COVID time itself, you would have seen. So several robotic researcher, they have actually like sent for drug delivery robot or food delivery robot or medical dispenser like that. They have actually like developed robot mostly mobile based with basic arm, right? Mobile manipulation in the sense. So apart from that, you can see, so for example, material handling. So material handling in a warehouse is a big task. So too much money is spent by so many people. So then the simplest solution came with a simplest mobile manipulator. You will not, you can say, accept that it is a mobile manipulator. You can see it can lift the tray or rack with a small arm, and it is a simple differential wheel robot. It can carry the entire rack. So this is what in the modern world the inventory, or you can say the warehouse automation is happening. Whether it is actually like you take, so it's Amazon or you can say eBay, whatever you take now, the logistic industry is using almost like a similar solution. Because the other solution, which is very expensive, with the mobile manipulator with the proper arm, that is very, very expensive. Almost 1.5 crore, one single system. But this is actually like less than 15 lakhs with which can actually like carry almost the entire rack. So that is the way. Another, you can say, warehouse robot also have come. This is called squid, like how squid is actually like floating like that. So this can actually like move on the rack on the warehouse. So it is not only ground based, it can actually like climb on the rack. This is also mobile manipulator. So you would have noticed that this has an arm. This arm can actually like carry the thing. And this is the fetch robot you would have seen many times. And this you call spot with the manipulator arm also you would have seen. The handle, which is another, you can say, two wheeled leg to robot, which can use for uh, warehouse automation. This also would have seen. And a similar way you would have seen the mobile manipulation for agriculture side also, right? So this is the modern autonomous mobile manipulator. So the idea here is actually like very simple. I just want to give a, you can say, glimpse how the mobile manipulator is actually like interested, or you can say ruling the modern world. So now, when we talk about autonomous mobile robot, many of you may ask, sir, AGV, which is automated guided vehicle, also started, you can say, evolving in 80s, and even most of the modern industries, AGVs are there. Yes, I do agree, but AGVs are actually like very cost, you can say, expensive, because they, you call, the infrastructure should be actually like more dedicated. For example, this is one of the AGV plant. If this magnetic strip is actually like cut, so this entire robot layout would be stopped, because it cannot actually like understand this tape is actually like disconnect or something. And apart from that, if any changes happen in the layout, then you have to actually like change the command, and you have to stop, and you have to do the repair work, or you can say readjustment, rescheduling, everything you have to do it. So for example, now this lady is coming. For example, she would have stopped here. This entire layout would have stopped. But if it is a AMR, that is not the case. So the AMR is actually like much flexible. For example, now they restricted the area. So this robot can actually like take the map already available. It can take the reroute, and it can go. And even the layout is slightly changed as long the space is there. It can go. For example, now it is collaborating with the human walk. It sense. Now you can see that this is actually like restricting this path, but still it is actually like navigating and going. So these kind of advantages are there in AMR, and the capital cost seems to be, it is high, but after the rigorous study, people identify that AMR is cheaper than the AGVs. So even I had actually like experience in AGV plant in Maremalai Nagar. I visited when I was in IIT Madras. So the challenge is actually like very, very high in AGVs. Even the workers who is working there, they can actually like push it so that the entire unit will stay idle. So that kind of changes can happen. So then you can ask, sir, AGV with a little bit, you can say can be fed it so that it can work. No, but as per AGV ISO norms, you cannot actually feed any intelligence to that. So if it is intelligent, then that should fulfill the ISO of the AMR. So then anyhow you are going to bring the AMR in line. So then it is better to call it AMR itself. That's the whole idea. So now you all know like robots are actually like as I discussed earlier, it is no longer stick in a factory shop floor. It moved out of shop floor to even everywhere. You would have seen it start from entertainment to even hazardous environment like space, underwater and all, right? So in that case, one of the biggest question for us, when and where to use robots. If you go with the classical side, so people say that dull, dirty, dangerous. If any one or any combine of this, then you can use robot. Then this is not the one which brought the modern robots, right? We are seeing now so many manipulators in place, right? If we stick only these three keywords, we would have not stopped. Then people thought that we can actually like bring the conventional side, the dangerous and difficult they added. So the difficult and dangerous is not that different, right? And this is also not successful for the bringing up the robots in the industry. The change of the keyword, the difficult to dear has changed. So whenever you say dear, you don't think it is close to your heart. So this dear is the industry aspect, which means actually like you are economic or you can say some kind of profit oriented. If any installation is giving economic benefit, then which we can call dear. So in the sense, the robotic installation bringing any economic benefit, you can adapt. So this adaptation only brought the modern, you can say, robots which are in place. Okay, but I already told these all specifically for industry, but we are actually like talking about domestic and you can say any other field. So in the sense, the DR may not be required, domestic can be replaced, and for flexible layout we can replace with dexterous. So now we are working on the current 5D. That is the whole idea. Now you can actually like ask in India, so lots of you can say human is there, why you are bringing robot, you may ask. So whether these people are actually like jobless. So for that you should have an answer. You see, when my father or grandfather age, you go to any village, the educated people would be very very less, 10 to 20%. But now you go to village, so how much actually like non-educated, if you look at it, only 10 to 20%. Now it is 80 to 90% are educated. Earlier it is 80 to 90% as uneducated. So when there are lots of uneducated, so you have to give semi-skilled and unskilled job. But now educated are there, you can give more skilled and you can say almost zero unskilled job. So the unskilled job you cannot actually like ask the human, right? So that is what the current status. So you see the unskilled jobs are actually like now is actually like not many takers. So that's why we are actually like bringing the robot. But if you are bringing the robots, so you will bring lots of jobs. For example, you are bringing one, imagine one agriculture robot. This robot is actually like going to, you can say, bring some two or three manufacturer as a job, then some maintenance, some marketing, some training, some operator, right? So like that, some other jobs it would be creating. And if it is one become 10, so many jobs created. This 10 become actually like 100, one industry will come. Like that, it is actually keep booming. So in the sense, you have to see where we are standing. Don't we should not see the old keywords. So India is having a huge manpower and we are having a jobless. But you just call any, you can say, really unemployed guy, ask him or had to do a regular labor job, they will not do it. They are not ready to do it, right? So, for example, the daily wage job, 350 to 400 rupees per day, you ask, they will not come. So that's why the you can say agriculture field is actually like having a lack of manpower. That's why we are trying to bring lots of mechanization and automation. right? So in that sense, you can see this current 5D is exactly matches when and where to use robots. And I want to give small glimpse where we are actually like lacking. So you all know like this is one of the Boston Robotics, Boston Dynamics robot called Atlas. So this is one of the successful attempt of a obstacle run of this Atlas. You know that this is one of the highly intelligent robot, right? You do agree. But you know how many times it failed. So how many engineers behind their work? How many algorithms they have tested? These are all the things you may not be knowing. So why these things are required? Because you are seeing only the successful side. But when you are evolving as a robotic engineer or you can say mechatronic engineer, you should know the background, the basic physics and how to actually like caliber that physics that you should know. So the Boston Dynamics, you know, like it is 80 started. So from 80s to 2023, they have reached this way. So almost like 40 to 60 years they have spent this much to reach this much, right? So that's what we are lacking. This mechanics part, or you call the understanding physics part, is missing. So that's a bigger problem. That problem is actually like we are trying to rectify. So that's what I try to show that. So for example, any robotic engineer or design engineer will get task to be completed. For completing the task, we have to have real system. For example, the machine assembly would be done with a small SCARA robot as the idea. So now from the task to be completed, what we know, what is the design specification? The desired specification which evolve to what kind of configuration we need. But based on the configuration, I cannot actually like directly plug it. For example, even I decide to go with the SCARA robot will come from 10 lakhs to even 10 crore. Which one I can choose? What for I can choose? That I need to know, right? So in the sense, from the real-time side, you can see selection of sensor, actuator, and mechanical structure. Even one more also we can add selection of controller. But selection of controller is actually like integral part, so we will not see that way. So now this side, these are the selection, and this side, this is the selection. Now somebody has to fill this gap. So this is the gap which we call system dynamics or mathematical modeling. So in this sense, the mathematical modeling is to understand the behavior of the system and to design the mechanical system, and apart from that to design suitable motion controllers, navigation system, and adjust their performance. This is the way we can do. For example, if you are thinking about a mobile robot, the mobile robot navigation system need to be designed. So without any proper understanding you cannot do it. This proper understanding will give some layout how to adjust or how to, you can say, design the navigation system. So that is what the idea. For example, some of you may be familiar with so particle filter or extended Kalman filter. So sometime if you look at it, so there the measurement update is one side, but the system update is the other side. For the system update, although you have inaccurate model or uncertain model, you would take it as the core. So in the sense, you need a small skeleton to build. So that is what, and later part, even the mathematical model can be used as a system estimation or you can say system identification. Okay. So that way, if you look at it, the system is actually like keep going on that way. So the trends on the robot motion control evolved in a different way. Right now, we are sitting in a AI robotics world. So, but the world is not suddenly has come up. So the classical days, mid 70s. So the robots are actually like a mechanized system in the sense. So you made model, that model is accurately work, and when it is failing, they replace that in the sense. So they depend on heavily on the system models. Okay. So no sensing, nothing was there. For example, so 10th second it reach 1 centimeter, it will reach like that. So it will actually like you turn 30 degree, it reaches, you can say 45 degree, you can say you turn 30 degree, it reaches 1 meter, it reaches 1 meter exactly. Like that, it made it earlier days. So that is what we call classical robotics. There is no control, it is all open loop. So it's like inverse dynamics or inverse differential kinematics like that. It's a feed forward control. But that is not so successful because over the period wear and tear, some environment changes, even manufacturing defects, everything can endure. So people thought that why can't we change? Then they brought suddenly into a reactive paradigm. Even in 80s only the PID controller all start moving up. So the people what they did wrong is they ignore the model and they heavily depend on the sensing. So the sensing was actually like good. The reactive or you call so motion control was very popular. So this is model control, model based control. This is motion based control. So motion based control was working well as an actuator level. But if it is a system level, it was failing. For example, you have 2 hour serial robot. The first joint is actually like plus or minus 1 degree is acceptable. So, but when you see the second joint, so this is 1 degree error. The second motor also you have put plus or minus 1 degree, but it accumulate to 2 degree error. So which is actually like avoiding the allowance, right? Because we said plus or minus 1 degree, but your previous and this one accumulate and it is giving. So that's what the challenge is. So then people thought that the good sensing and exact model can be combined. That is what hybrid model. So model based at system level and reaction or motion based at actuator level. So this was so popular. Even now, people are working in this hybrid model. But these are all successful in manipulator side, but mobile robot side these are not successful because in mobile robot, so the system is actually like mobilizing in an unconstrained, unknown environment. Then you should know like some kind of prediction. So when you talk about prediction, what we usually bring it in immediately in our mind will bring the probability. So then the probabilistic robotics have come where no exact model, no proper sensing. Both can be actually like seamlessly integrate and make it work. So this is what 90s, mid 90s onwards. So this is what even now most of the mobile robot community working on probabilistic robotics. So the base filter is the source filter, but now people are actually like working upgraded version of EKF, particle filter or combination of this even further development and all. But what happened after the computers all boomed, specifically the data science are actually like start booming. So the data driven models are so popular. The data driven model were so even then it is 2000 onwards it is existing, but those days the data driven model is large, you can see memory carrying and heavy computational expensive. But in the modern world, the data driven is actually due to deep learning and reinforcement learning. So the learning based control schemes are actually like more or less popular in the modern world. And this is the robot evaluation, which we are looking the dynamic walking. You would have seen that the foot is actually like about to hit, and this foot is actually like about to lift. But before that, you can see that at least one foot is in rigid support. So in the sense, it is a static walking, but we are looking for a dynamic walking. We start from manipulator, and we are enriching or you can say envisioning this dynamic walking. We are achieving only static walking. Very few attempt happened in dynamic walking. Even you would have noticed elbow bow, or you can say so there is actually like knee bend and knee stretch. There are two more. So you would have seen the humanoid robot. Most of the popular humanoid robot, even Honda Simo, you would have seen that the knee bend configuration. It is not fully stretched, but you would have seen this. You can Atlas. So which is actually like you can see stretch base, knee stretch base. So that is the difference. So if you look at it even Navo or Asimo, whenever you command anything, it will come into a stable pose, which we call home position, and then it's doing that work. Why? Otherwise, the static walking or static mode will not be enabled, then it can fail anytime. For example, so the Nava robot you take and ask to walk and suddenly you ask to jump, it won't do. That is the major challenges. Okay. So now if you are looking at that way, so there are many mobile manipulator based on the application, the robot can be classified in multiple fold. So for example, you can see this is assistive robot. This assistive robot is with a wheelchair. So this is actually a cooperative robot or collaborative robot. You can see a larger payload combinedly handling with mobile manipulator, and you can see it's a domestic application which is kitchen robot, and this is actually like a hybrid where mobile manipulator with wheel or legged base. So like that, many configurations are available, and it is upcoming also. Even you would have seen so parallel robot with multiple parallel robot on ground base, which is actually like giving a flexibility to assemble objects and all. For example, heavy construction. So they need to actually like lift a heavy object and insert in particular location, which is very expensive, right? So lift need to be required and the crane need to be installed. So instead of that, few mobile manipulators can come and it can lift and it can actually like rotate the orientation and it can insert. Like that, collaborative robots have start coming. And when you talk about agriculture, so I put one of the fancy feature. Why I put elderly people? Because in the modern world, younger people are not ready to do this paddy plantation and all. So now you want to do this. What is in your mind? Don't see immediately an anthropomorphic robot which is going to, you can say, stand on this muddy field and pick the bunch of, you can say, paddy, you can say sapling, and it is actually like collecting 3 4 and it is actually like inserting into a muddy. It is actually like very expensive and it is challenging as well. I can complete probably 10 to 15 PhD if I do that way, but that is not the best solution, right? The solution can be even manned one or unmanned one. The manned one, so the manned one is actually like a small tractor with a plantation tool. You can see that. So this is a manned one. So the same thing, you can make it a driverless. You can actually like see this. So it is unmanned one. So this is the way we have to think. Don't see the direct solution, but you can see the solution is actually like possible even in a simpler sense. So now it is actually like autonomous tractor with paddy sapling tool. That is the case. So similarly, one of the biggest area, so there are many, but I put a small toilet cleaning mobile manipulator. So which is actually like one of the somatic configuration. You can see this is there demonstrated for the hotel, because hotel every then and there they have to actually like clean the toilet and as well as room cleaning. So this particular robot they demonstrated for the hotel. So you can see that this robot will go to the nearest toilet and it will actually like do all those cleaning work and wiping work. So you can see like mobile manipulator can do many things. So that is what I just want to convey. So with that, I'm actually like stopping it here. Okay. So you can actually like come back if any questions, one or two, because as I already told, I have to go 3:30 to our director office for a meeting. But when you come to the future robotics, the mobile manipulator are the best thing. But there are two contracts objective which will come. One is regular routine task. For example, here I put a warehouse maintenance or inventory maintenance. The other one is actually like companion, which is going to do, you can say, human supported robot. So now you can see that there are two things. I put these pictures specifically. You can see it is open. You can see the brain is not closed, and here you can see it is closed. And the fancy picture you can see like it is not bothering what is the next command, but here you can see this picture closely. Look at it. She is moving something, and this robot already know what to do. That kind of intelligence. But these are the two objectives. Contracts objective. One is regular routing, which is actually like mass. The other one is actually like few particular intelligence. That is what the contracts thing. And when you look at that way, there are four important entity we have to focus. Any robotic researcher in the modern world, they are bothering this. The robot should be human friendly and it should do its own environment mapping. And the robot should not be restricted with one single function. It should have multifunctional. And the robot should have its own privacy and should maintain others' privacy. And as well as it should secure itself and as well as should not harm anybody else. That is the case. So then this cartoon is actually like although very old cartoon, but that matches. So for example, this is human friendly and it is multifunctional and it is having a privacy and secure based on this antenna. and it is actually like mapping with this, you can say, sensor. That is what the idea. With that, I'm closing and saying thank you. So please let me know if you have any specific question. Otherwise, we can actually like move further. I just give small glimpse. So the detailed research, if you want, I'm working in this mobile manipulator last 10 years. So lots of attempts we have made. A few papers are there, few prototypes are there. So you can always reach me whenever you have. And apart from that, IIT Palakkad used to have summer internship at our institute. So during summer, it's a paid internship in the sense. So for 50 days, it is paying around 9,000 to 16,000 according to the duration. And this would be advertised. And apart from that, our PhD positions also like opening twice. And our institute is actually like UAP based. So if any of your faculty willing to do their PhD, they can reach. So the QAP is actually like a national wide call. Recently, one round is over. The next round will come probably May, June. So you can actually like follow up and you can see our professors and then reach them also for that. With that, I'm closing. If anything, you please let me know.
Thank you, sir. Sir, Mr. Rajesh sir asked for multifunctionality means. What is please, please?
I didn't get the multifunctionality.
Uh, Mr. Rajesh sir, can you ask in mic?
So the word itself multifunctionality, right? So it means actually like it should not be restricted to one function. For example, I make one robot for just room cleaning, so that may not be sufficient. Only with a wiping tool, that may not be sufficient for. So if you are actually looking at, it can do multifunctional. That's the idea.
Okay, thank you, sir. Dear participants, any other queries to sir? Sir, one more participant asked for what is the current and future social impact of future ultra smart computational cyberspace driven by artificial intelligence and humanoid robots?
So humanoid robots I cannot address because humanoid robots is very difficult. So for example, I'm giving a stick in front of you and asking you to stand the, you can say keep the stick vertically up in your palm. So how difficult that way? That is the way the difficult in anthropomorphic robots, specifically humanoid. Apart from that, humanoid stability and dynamic walking. So the intelligence also like another challenge. So although you may look at into AI algorithm, that too like ready-made algorithm is more popular, but I'm thinking like there is a lack in intents. So for example, so the cyber physical space comes, but who will develop these all? That area is still vacant. For example, I've seen, so I used to go different colleges for different purpose. So I've seen that most of the students, so even the bright students, they said, sir, I want to do my BTech project in A base or probably like a mini project in A base and all. But they are actually like forgetting the physics behind. So they are actually like seeing that too like most of the students, they're not even bothering about how the algorithm works. That is much pathetic. So now if this goes, the societal impact before the AI and robotics is going to make, so our knowledge base is actually like going to drain. Only like some intelligent people become intelligent and intelligent. Okay, like olden days. So you would have seen like one set of people always like highly intelligent, other set of people are dumb. That scenario can happen. This is the socio impact is going to happen. Already you would have noticed. So even in your class, you would have seen, some of you are faculty, right? You would have seen in your class the above average students are actually like getting better result than the below average student. Below average student is actually like very poor compared to 10 years back. And above average student is actually focusing only one set. Not everybody is actually like focusing everything. So that is also a problem. The social impact before pitching into a what you call cyber physical space, this is actually like killing everything. Right? You,
Thank you,
no,
sir.
no, it's happening. Many people are trying, right? So
Any
even
other queries?
CBSE and all now, so everything is actually like in part. So, but the problem is whether they are actually like taking into serious or not. That is what the problem, right? So that is the see, physics they are studying in normal physics. For example, you give one small problem, so you just ask them to throw the stone and see where it reaches. So they can do a very simple physics, right, which they studied in their school physics, simple projectile and all. But not many of them are ready to attempt. So only thing you have to cultivate them with a practical system. So then you need a huge investment. So now everyone cannot make the prototype. Even virtual prototype, several ready-made tools are there. For example, I say virtual prototyping, then even in robotic system, people go with the ROS. They don't know like how the ROS works. They just plug and play. Even there are several plugins are available. Even the plugins, how it is working, people are not knowing. That is the problem. So that problem can be addressed only if the students are actually like so serious on their what they wanted. Then only it can be. You see, research proposal is actually like slightly a different topic. So how I used to do research proposal means, for example, I am planning to do something like selective harvesting of fruits as the research topic. First, I will do harvesting. So I'll just Google Scholar or probably some kind of search engine. I'll just do it. In that, how many attempt on selective harvesting? In the selective harvesting, how many of them are design attempt? How many of them are control attempt? How many of them made prototype? Even in the prototype or in the design, how many of them are focused on certain class of fruits? Why not the other fruit? Then I will actually like make a tree. So I make it actually like one single Google shared folder. So where I actually like download whatever attempt. So I just start copying. Then I will actually like classify. When I click that folder, I can see the mapping like tree branches, sub branches like that. Whenever I am reading, I just put some kind of, you can say, add on script also. For example, this paper attempt with so and so thing. So now what happened, that will give some kind of loophole. When I see a broad spectrum, okay, so selective harvesting 120 attempted. So in that 120, 40 on mangoes, 20 is apple. Okay. So now we are actually